to Science Hub. My name is Kalpit and today we are going to learn about hard disk and file systems. So the module objective is hard disk drive, solid state drive, physical and logical structure of a hard disk, types of hard disk interfaces, hard disk components, disk partitions, file systems, types of file systems, Windows file systems, FAT and NTFS, Linux file systems, ext2 and ext3, CD-ROM, DVD file system analysis using the sleuth kit TSK. So let's begin with disk drive. Disk storage is a storage mechanism that reads data from the disk and writes data onto a disk. A disk drive is a storage device implementing such a storage mechanism with fixed or a removable media. The disk in the disk drive rotates at high speed and heads in the disk drive are used to read and write data. There are two types of disk drives. Number one is fixed storage drives and number two is external storage drives. Fixed storage drives can be the internal hard disk and SSDs, and external storage drive can be CD-ROM, DVD-ROM, zip disk, etc. So there are two types of storage drives. Number one is internal storage drive and number two is external storage drive. Internal storage drive example is hard disk and external storage drive example is thumb drive, PDAs, memory cards, DVDs, CDs, etc. So let's move on to hard disk drive. Hard disk drive is a non-volatile random access digital storage device used in any computer system. The data is recorded magnetically onto the hard disk. There are three main components of the hard disk, which are cylinders, head and platter. A high-speed spinning platter used as the recording media and data is stored on the tracks of the sectors. Solid state drives or SSD. SSD is a data storage device that uses solid state memory to store data and provides access to the stored data in the same manner as a hard disk drive. It uses microchips to hold data in a non-volatile memory chips and does not contain any moving parts, hence solid state drive. It is very expensive per gigabyte. It uses two memories, NAND based flash memory. It retains memory even without power and volatile RAM. It provides faster access. See the structure of a hard disk. A hard disk is a sealed unit containing a number of platters in a stack. It is fixed in a horizontal or vertical position. Electromagnetic read and write heads are positioned above and below each platter. As the platters spin, the drive heads move in towards the center surface and out towards the edge. Let's understand these three terms. First, track density. Track density is defined as the number of tracks in a hard disk. Number two, a real density. A real density is defined as the number of bits per square inch on a platter. And number three, bit density. It is bits per unit length of a track. The data is recorded in the hard disk using the zone bit recording. Zone bit recording is a technique of grouping tracks into zones based on their distance from the center of the disk. This is the image of a hard disk. This is the physical structure of a hard disk. Let's see the types of hard disk interfaces. There are 5 types of hard disk interfaces. SCSI. SCSI means Small Computer System Interface. It enables connection of 15 peripheral devices to one PCI board. Number 2, ATA. ATA is Advanced Technology Attachment. There are two types of ATA, Serial ATA and Parallel ATA. USB. Universal Serial Bus. It permits electronic equipment to connect the computer. IDE or EIDE. Integrated Drive Electronics or Enhanced Integrated Drive Electronics. It connects hard disk, optical disk and tape drive to the PC. And lastly, fiber channel. Fiber channel electrical interface or fiber channel optical interface. Now let's see disk platter. Platters are the round flat magnetic metal or ceramic disk in the hard disk that hold the actual data. They are made up of two components, substrate material and a magnetic media coating. Magnetic media coating is done on the part where data resides by an iron oxide substance or a cobalt alloy. Numbering is done on both the sides as side 0 and side 1. Data is written on both sides of a hard disk platter. Tracks. A concentric circular ring on both sides of each platter is known as a track. Drive head can access this circular ring in one position at a time. Tracks are numbered for identification purposes. A modern hard disk contains tens of thousands of tracks on each platter. Read and write is done by wheeling headers from inner to outermost of the disk. Tracks numbering. Tracks numbering begins from 0 at outer edge and move towards the center, typically reaching a value of 1023. Heads are moved in and out jointly so that the both heads are always located together at the same track number. A cylinder is a group of all tracks that start at the same head position on the disk. Sector. Sector is the smallest physical storage unit on the disk platter. It normally holds 512 bytes of data and a few additional bytes for drive control and error correction. Factory track positioning data determines labeling of the disk sector. Data is stored on the disk in a continuous series. For example, if the title size is 600 bytes, two 512 sectors are allocated for the file, and this creates slack space. Let us see sector addressing. Cylinders, heads and sectors determine the individual sectors on the disk. For example, on formatting a disk, 50 tracks are divided into 2 sectors each. Track and sector numbers are using the operating system and disk drive to identify the stored information. Slack space. Slack space is the free space on the cluster after writing data on that cluster. DOS and Windows utilize the fixed size clusters or for the file systems. If the file size of the stored data is less than the cluster size, the unused area remains reserved for the file, resulting in slack space. DOS and FAT16 file system in the Windows utilizes large sized clusters. For example, if the partition size is 4 GB, each cluster will be 32 kilobytes. Even if a file needs only 10 kilobytes, the entire 32 kilobyte will be allocated, resulting in 20 kilobytes of slack space. This is the diagram of a slack space. OS marks cluster as used but does not allocate them to any filer. Such clusters are known as lost clusters. It can be reassigned with data, making the disk space free. They are the result of the interrupted file activities like the file is not currently completed and closed. Thus, clusters never get properly linked to a file name. Scan disk utility can identify the lost clusters in DOS and Windows operating system. Bad cluster. Bad sector is a damaged portion of a disk on which no read or write operation can be performed. Formatting a disk enables the operating system to identify unusable clusters and mark them as bad. Bad sectors are due to configuration problems or any physical disturbances to the disk. Special software is used to recover the data on a bad sector. Master boot record (MBR). A master boot record is the first sector 0 of a data storage device such as a hard disk. The information regarding the file on the disk, their location, size, and other important data is stored in the master boot record file. In practice, MBR almost always refers to the 512 byte boot sector or partition sector of a disk. MBR is used for number 1, holding a partition table, which refers to the partitions of a hard disk, number 2, bootstrapping an operating system, and number 3, distinctively recognizing individual hard disk media with a FL-bit disk signature. Let's see what file system means. All the file systems consist of structures necessary for storing and managing data. These structures typically include an operating system boot record, directories, and files. Functions of file system are tracking allocated and free space, maintaining directories and file names, tracking where each file physically is stored on the disk, and lastly, a file system is set up on a drive during a format. There are several types of file systems such as shared disk file systems, flash file system, tape file system, special purpose file systems, network file systems, and database file systems. You can go through all of them by pausing the video. See some popular Windows file systems. Number 1, FAT file system, FAT12. The initial version of the FAT file system, FAT12, was introduced in 1977, even before MS-DOS, and was the primary file system for Microsoft operating systems up to MS-DOS 4.0. FAT12 supports drive sizes up to 32 MB. FAT16. The second implementation of FAT was FAT16, introduced in 1988. FAT16 was the primary file system for MS-DOS 4.0 up to Windows 95. FAT16 support drive sizes up to 2 GB. And lastly, FAT32. FAT32 is the latest version of the FAT file system. It was introduced in 1996 for Windows 95 OSR2 users and was the primary file system for consumer Windows versions through Windows ME. FAT32 supports drive sizes up to 8 TB. Here FAT means file allocation table. This is a diagram of FAT file system. Number 2. NTFS file system. New Technology File System or NTFS is a file system that was introduced by Microsoft in 1993 with Windows NT 3.1. NTFS supports hard drive sizes up to 256 TB. NTFS is the primary file system used in Microsoft's Windows 7, Windows Vista, Windows XP, Windows 2000 and Windows NT operating systems. The Windows Server lineup of operating systems also primarily uses NTFS. NTFS provides for enhanced security file-by-file compression, quotas, and even encryption. The file allocation table or FAT file system was the primary file system in Microsoft's older operating systems, but it is still supported today along with NTFS. Popular Linux file systems. Number 1. ext or Extended File System. First file system for the Linux operating system to overcome certain limitations of the MMIX file system. It is replaced by the second extended file system, ext2 or Second Extended File System. Standard file system with improved algorithms used on the Linux operating system for a number of years. Not a journaling file system. And lastly, ext3, Third Extended File System. Journaled file system used in the GNU or Linux operating system. It is mounted and used as an ext2 file system. It uses file system maintenance utilities like fsck for maintaining and repairing alike ext2 file system. Now let us see RAID storage system. Redundant array of inexpensive disks or RAID is a technology that uses multiple smaller disks simultaneously which function as a single large volume. It provides a particular method of accessing one or many separate hard disks, thereby decreasing the risk of losing all data if any one hard disk fails or is damaged, and improving access time. This technology is developed to maintain a large amount of data storage, achieve a greater level of input or output performance, achieve a greater reliability through data redundancy. Now let's see some tools. The first is the Sleuth Kit or TSK. The Sleuth Kit or TSK is a library and collection of command line tools that allow you to investigate volume and file system data. The volume system media management tools allow you to examine the layout of disks and other media. It supports DOS partitions, BSD partitions, MAC partitions, Sun slices, and JPT disks. It analyzes raw, expert witness, and AFF file system and disk images. It supports the NTFS, FAT, UFS1, UFS2, ext2FS, ext3FS, and ISO 9660 file systems. This is second tool, HXD, which is a hex editor. Thank you. If you have any doubts, please comment them below.